Hi, this video is a guide for solving Math 1014 problem 743A. This is one of the most missed problems on 1014 quizzes. This problem involves deducing the trigonometric function that's plotted in the graph. Now certainly some of these are harder than others. It sometimes just depends on the luck of the draw. But if you just apply what you know about the general form of the sine and cosine functions, you can reason your way to the correct answer without too much trouble. Okay, so before delving into any of the actual problems, let's take a look at the general form of the sine function. Cosine is going to be basically the same, and we'll talk about the differences in a little bit. But for now, okay, so we know the basic form of the sine function just looks like this, and we know what this actual function looks like when it's graphed. Okay, and we'll just draw it so that we can compare what happens as we start adding parameters. Okay, so this is 2 pi, this is going to be pi, we've got 0 here, 1 here, -1 here, and we're going to have a crest here and a trough here. Okay, so this is what it looks like in its basic form. Now there are 4 parameters that we can add to this function that will have some effect on its shape. There are 4 of those, and we'll go ahead and write the whole form out now. So it's f of x is equal to a times the sine of b times x, there's that original x, minus h plus k. Okay, so we see that we've multiplied something by the sine, we've multiplied something by the original angle, we've subtracted something from the angle, and then we've added something to the whole expression. So let's go ahead and take a look at the effect of each of these on this original wave. So this A refers to the amplitude. And the amplitude is this height right here. So from the axis to this crest. So that's A. And this is also A. Now it's negative, but it's the same magnitude. So that A is the amplitude. So in the basic form, we just have A equal to 1, and we see that that distance is 1 right there. But let's see what happens when we change the A. So I have a general sine function here, and I'm going to plot it with the basic parameters. And A here we see is equal to 1. So let me just go ahead and make this range from 0 to 2 pi. Okay, so this is our basic form with the parameters all set to their default values. If we were to change this, we see that right now the amplitude is 1. Change this to 2. The only effect this has is on the height here. So this is now up to 2. And we can change it to 5, and then it's up to 5, etc. So that's what amplitude does. Now we can get sneaky and put in a negative here and kind of flip it around, but we're not going to worry about that right now. Okay, so that's what A does to this. Okay, so let's take a look at K now, this one right here. So K is the vertical shift. That is, how much this original form is pushed up or down. We can nudge it up. So if K is positive, it pushes it up. If K is negative, it pushes it down. So again, let's go over to Mathematica and play with that and see what effects we can have. Okay, so right now k is 0, so it's not pushed up or down at all. We see that its starting point is right here at the origin. If we were to nudge it up a bit, okay, so now the starting point is up here at 1, and it goes up to 2, and then down to 0, and then back up to 1. We make it 2, same thing, it's nudged up 2 now. So we can try nudging it down. So now it's here at -1 where it starts, comes up to 0, and then comes down here to -2, and then comes back up to -1. Okay, so that's what k does. And we'll go ahead and return it back to 0. Okay, so let's take a look at b now, the effect that b is going to have. And b is the number of cycles per 2 pi. So we see that in the basic case, b is just equal to 1. We've got one complete cycle of the sine wave here. Come back to Mathematica and play with that some. So we've got one cycle here. We can change it to 2 cycles. Again, this is from 0 to 2 pi. We can change it to have 4 cycles, change it to 13 cycles, and change it to have 100 cycles. So this, if this were a sound wave, this would be a high frequency. Okay, so return that back. So that is b. So the number of cycles per 2 pi angles. 2 pi radians, sorry. So now let's take a look at this last one, which is h, and the effect that this is going to have. So h is the horizontal shift. So just like we can nudge this wave up or down, we can also nudge it to the left or the right. And if we nudge to the right, it's positive, and if we nudge to the left, it's negative. Okay, and there's a couple of tricks there, so let's go ahead and take a look at this in Mathematica. So now we have our h. Because h is the value that's added to or subtracted from the original angle, that means that it's usually expressed as some kind of multiple of pi, because we talk about angles in radians here. So let's try setting h from 0 up to just a little bit. Let's say pi over 8. And I'm going to go ahead and change the range of this graph so that we can see what happened here. So this sine wave normally started here at 0, but we see that it was pushed over to the right by just a little bit, by pi over 8. If we nudge it a little bit more to the right, okay, so now it's nudged pi over 4 here, and pi over 2. We can also go in the opposite direction and nudge it to the left. Let's change this to pi over 8. So we see that it's been pushed just a little bit to the left. Instead of this starting point here being right here at the origin, it's been pushed over here to the left. Okay, now the reasonable question to ask at this point is, how am I supposed to tell a cosine from a sine if I can push a sine wave over a little bit and it would look just like a cosine wave? And the bad news is you can't. In fact, I have a demonstration right down here to show this. I'm going to plot sine and cosine with each other from -2 pi to 2 pi. The sine wave is here in the blue, and the cosine here, which as we know starts at 1 and then goes down, we see that these look a lot alike, just shifted over a little bit. And in fact, I am going to shift the sine wave over by -pi over 2. Okay, so remember that we're subtracting this value, so we're subtracting a negative value, so it'd be the same as adding a positive. But when I do that, these waves are sitting right on top of each other. So the bad news is you can't really tell the difference between a sine and cosine because they're shifted versions of each other. But the good news is we're not going to try to trick you with that. All the problems that we give you are going to have some kind of way for you to differentiate between the sine and cosines on the basis of these other parameters. Okay, so let's take a look at one of these problems now. Okay, so here's one example, an example problem that I've taken from the practice problem system. And over here, I have put the box that appears on your online text. And this is just what I was talking about before. There's our A, and our B, and our H, and our K. And this just summarizes what we were talking about: amplitude, and B is the number of cycles, H horizontal shift, and K is the vertical shift. Okay, so let's see if we can figure out which of these functions down here is depicted on this plot here. Okay, so the first thing we'll take a look at is the vertical shift. We can tell just by looking at it that most of each of these waves is below this x-axis. Much of the mass here is pushed down below, so we've only got a little bit up here and a lot here. So we clearly have a negative vertical shift. So the vertical shift occurs here at the end. These are our k values, and we can see right away that we've got this one would require a positive vertical shift, and so would this one. Okay, so we're already just down to signs here. All right, so let's see what else we can figure out here. We can try looking at the period now, that is B, or the number of cycles. So we've got like 1, 2, 3, 4 here, maybe 4.5, so 9 halves. It looks like both of these have 9 halves, so that's not going to help us deciding between these two. Okay, so now we're going to have to take a look at H, because we don't have any A. Amplitude appears to just be 1 still, and in fact we can kind of imagine that there was a 1 here, so A is equal to 1 in both cases. So now we have to see if there's any kind of shifting going on. We see that there is a shift here, so H is equal to 2 pi over 3 here, and it's equal to 0 here. So the question then is, does this thing have any kind of shifting going on? Well, let's take a look. So we know that it's a sine wave, right? And sine waves normally start at 0, but we have a negative shift here, right? So it should be starting at negative 1/3, okay? And we can't really tell much by looking at this. But one thing we also know about a sine wave is that it starts by going up, not by going down. So we can see clearly that this has something other than a 0 shift. It's got some kind of shift. We don't really need to know that it's exactly this, but we do know that this has been shifted to the right. So that means that this is going to be our correct answer. Okay, let's take a look at another one. Okay, we'll take the same approach, looking at the vertical shift first. So what can we tell by just looking at this? Well, most of the mass here of these waves is down below the axis, so we've got a negative vertical shift. So right away we can get rid of anything that appears to have a k that's positive, so we'll cross that off and cross that off. And so, okay, so now we're down to just cosines here. So and now let's take a look at the periods, that is the number of cycles we're seeing. Again, this is from 0 to 2 pi, so how many cycles do we have? We got 1, 2, 3, 4. Looks like 4 complete cycles. And so this is our B, that is, this is the number that's multiplied by the x, that is the angle. And we see that we've got a 4 here, and this would be 1. So there's an implied 1 in here. So we clearly have more than one cycle in this 2 pi area here. So we see 4. So we don't even need to worry about what's going on in here. We already know that it can't be this. So this is going to be the right answer. All right, let's take a look at one more. So on this one, we see that we clearly have a vertical shift that is positive. So we can go ahead and eliminate these choices that would involve a negative shift. Okay, so now we're down to two signs. Once again, we see that we have the implied 1 for amplitude, so amplitude appears to just be 1 again. And we can't really derive anything from the number of cycles because looks like we've got 3.5 cycles here, and both of these have a b equal to 7/2. So once more we have to look at whether there's any horizontal shift. This one would mean there's a negative horizontal shift to the left, and this one would mean there's 0 horizontal shift. So the question is, does this look like a normal sine that has been just nudged up a little bit? If it were a regular sine that had just been nudged vertically up a little bit by 1/6, we should see the wave starting at like 1/6, or half of 1/3, or 0.16, like way down here, and then it would start its journey upward. So we're clearly arriving at this thing partway through a wave, so there has been some shifting here. So we can see that we can now eliminate this one, and this is the correct answer. Now, if your reasoning fails you on these and you've got the time and the stakes are pretty high, you might try to just go ahead and see if you can put in some values to see if you can find out where the wave should be at some point. So let's go ahead and see if we can do that. And let's just start with 0. Okay, so if this one is correct, where should the function value be at x equals 0? So let's go ahead and figure that out. Okay, so we've got x equal to 0, so we've got sine of 7/2 times negative pi over 3 plus 1/6. Okay, so this is going to be sine of negative 7 pi over 6 plus 1/6. Okay, so the sine of negative 7 pi over 6, well, let's think about this for a minute. All right, let's go back to the unit circle and see if we can think about what that would be. Okay, so we've got, so this starts at 0. This is pi over 2. This is pi. This is 3 pi over 2. So if we have negative 7 pi over 6, or negative 7/6 pi, negative is going to take us this way. So this would be negative 6/6. So we've got one more 1/6 of a pi over this way. So this is the angle in question. So right there. And so because we've got 6/6 plus another 6, so this is going to be the same as sine sine of pi over 6. And so sine is positive in the second quadrant, so sine of pi over 6 is going to be 1/2. Okay, so that whole thing is 1/2 plus 1/6. So we've got 1/2 plus 1/6 sixths, which is going to be 4/6 or 2/3, which means it's going to be like approximately equal to 0.6. Okay, so when x equals 0, f of x is equal to 0.6. And so we can see just by looking over here that looks to be about where that is starting. So we got a little bit more evidence that we're dealing with the correct answer right here. Okay, so I think that kind of sums it up. The way to go about these problems is to just think about what each of these 4 parameters does to the shape of the function, and just work your way through them, and it shouldn't be too difficult to land on the correct answer through, if nothing else, process of elimination. Okay, hope that helps.